And it should it'll begin to make more sense why you go to the thousandth, why you go to the tenths, why you can just round to the nearest whole number. Okay? As we get into more general, practical problems, then the rounding begins to make sense. If you're going to use a number that is going to be continuing, you're going to use that number as a dividend, as a factor, then don't round. You want that number to be as small, as exact as possible. Because if you round up, then your answer is going to be different. I can show you where two numbers equal at one valuation, and they're actually different by the time you get down to the thousands. Different. Now, is that difference and that subtlety, will that make a difference? If it makes a difference, I will indicate. Round to the nearest thousands. Well, why? Right after round to the nearest thousands. Because you're dealing with a 3-pound, okay, preemie. And you're going to give medication by what? Body weight. And you have to take the pounds and convert to kilograms. And then from the kilograms, you're going to determine how much to give this child. When I say round, okay, your answer in kgs to the nearest hundredth, do it. Your answer will be different. And on my exams, it will actually have 2-3 different answers that if you didn't round right, you'll choose the answer thinking is right. And it will be wrong. That's the tricky part. Are you paying attention? Do you understand the importance, okay, of valuation in medication? So, you are held accountable 3 digits to the right. And that digit is what? Thousand. Not to be confused with what? Thousand. Small percentage get that wrong on your quiz. I will. In a minute. This digit, what is it? Hundredth. Hundredths. This digit. Tenths. Tenths. Hundredths. And thousandths. ETH. Not to be confused with tens, hundreds, and thousands. That number is 156,000th. 156,000th. That number is 2 and verbally. That number is 2 and 48 what? Hundredths. That number is what? Please speak it. 2,126 and 1/10. 1/10. I do not go exactly in there. I know what's in chapters 1 through 3. I expect you to go through chapters 1 through 3. Any area where that you are not sure of, come to lab. Come to the labs. Okay? Thursday's lab will start. Okay? I will start labs this week, Thursday. I did come in a couple of times. I was here yesterday. Nobody came. I came Monday. Not sure. There were some folks here, so we had a good time. Yeah. The lab times are, I loaded them up in your cams. Okay? Monday is here. Tuesday and Thursday are conference room 3. Usually we're around 12, 13. If it's larger, I've got a room over in at Amaron. It is listed. I listed it up. It is on CAMS, and it actually shows the room number and the times. Please go into CAMS and get the information. Okay. You got your valuations. How many places are you accountable for? Normally, to the thousands, unless otherwise instructed. And that instruction will be round to the nearest bone. If it doesn't say, carry it out to 3 places. Now, if I say round to the nearest, if I say round to the nearest thousands, you have to look at what number? The 10 thousandths, the 4th number. Okay? That's 10 thousandths. You have to look at this one. The 4th significant digit to the right of the decimal. I have to be careful because significant digits includes numbers, the first number on the other side of the decimal in chemistry, right? Yes. All righty. So, if you're going to round to the thousands, you have to look at the 10 thousandths in order to see. So, if it's 5 or greater, the thousandths is rounded where? Up. If it's below 4 or below, leave the digit the same. You don't round down. Right? Good. Valuation. Done. Fractions. Fractions are no more than one thing compared to another. But we like to call it division. You do divide. It is division. It is one thing looked at how one thing goes into another or comparing. That is not an unfamiliar thing. We're always comparing, aren't we? Always comparing. And when you compare you to something else, you have put a barrier or a border between you and that thing, assuming that, well, maybe we're the same. Well, how do you know? You're the same because you gave yourself a 4 and you rated that a 4. Or you gave yourself, you're a 10 and all that, and you compared it to something that's a 10. That's division. That signifies that, what? You identified that you're both the same. There's nothing different with this. This is not a strange animal, but people don't like to divide. Oh, I don't want to divide. I don't want to divide decimals. Well, why not? You got a calculator. You grab it, it's the first thing you do is grab it. In here, we don't grab the calculator too quickly. Fractions. So therefore, a fraction is nothing more than something compared to itself, correct? And the way it's a division problem, now, I want you to take 0.1. You got it? You got the number? Make it a fraction. 156 thousandths, make it a fraction. It's just this. But do you know, I'll do that on the exam, and because there's like 20 questions and you got 10 minutes, you just, I didn't think of that. Yes! That's the fraction. Now, you don't leave it like that, do you? Because we'll do what? Reduce, reduce, reduce. Why do we reduce? Why do we reduce? We want to minimize the amount of magnitude of error. We're going to make some mistakes, but if you approach it right, your mistakes won't be irreversible. It'll be minimal because you're accustomed to the disciplines of reducing and understanding the importance of keeping things as small as you can. That's the whole great purpose of reducing. Okay? You will get penalized if you take initial approaches and don't reduce, especially something as obvious as this. People love what? They love to take 2. You can at least split this in 2. Why? Because there's two nice even numbers here. So that can at least be taken down quickly, right? So there's no excuse at least chopping this down. We don't want an error 156 times. I'd rather have it, when we make an error, chop it down, and you got half an error. Half the error you would have made, correct? Does everybody understand that? What is this? 500 and what? What's up with the top? Okay. 78 times versus 156 times is a little, it's not as big an error. Can this go down some more? Okay, take it down some more. That's reducing.
39 over 2.
All you did, what did you do? What did you do? You found common denominator, something that'll take this down, and also, you know, you can take that down. You got to find a common denominator, right? Got to find a common denominator. You will know. Here's the rule, and I catch it really quickly. Here is the rule that will determine and let me know if you have reduced a fraction to its lowest state. It will have a prime number in it. Well, what's a prime number? A number that can only be divisible by one and itself. Correct? Okay. Or the two have nothing in common. Okay? Both of those numbers may not be prime, but they got nothing in common. Anybody ever ever run into somebody they ain't got nothing in common with? You know that. Okay? Nothing in common. Just leave it alone. Got it? Okay? That's when you know that a fraction is at its lowest state. When there's a prime number in it, or the two numbers, numerator or denominator, have nothing in common. Great. Done? Study fractions. Now, I get a fraction. I get a fraction. Okay, everybody knows this, so just assume right now, nobody knows what 1/4 is. Nobody knows, okay? You got it? Please, go with me on this. You don't know what 1/4 is. How do you get it? 1 divided by 4. Okay? Now carry it out to the nearest 10th. Carry it out to the nearest 10th.
3.
Absolutely. Carry it out to the nearest thousands. Write it. I need you to write it. Carry it out to the nearest thousands. Now, there's no accident. This, I mark your answer wrong. It's wrong. The decimal must be preceded by a 0 if there is not a whole number. And for there to be a whole number, it has to be a mixed fraction. Think about that. Okay, for a decimal to have a whole number, it had to have come from a mixed fraction. Okay? Good. Put that down, and then you can talk to me later if you're not unsure. Okay? What did you get? Round 1/4 to the nearest thousands. Okay? You said 0.250. How many got it? Wrong. That's good. I was glad you said that. Thank you very much. See, I love it. Now let's suppose, here's the reason why. Remember, I always keep the theme. The theme is to what? Minimize or reduce the margin of. Let's suppose that somebody made a mistake and I just was crazy and you didn't, I didn't put a 0 there and you barely saw. Would you have preferred this to be a 250 error or a 25 error? Yeah. Don't put the 0. You do not subsequent this with a 0. The right answer is 0.25. Wrong. Right. And guess what? You will be quizzed on it and tested on it. This will be marked wrong, and now you're down to a 95. If you did this, now you're down to like an 88. And you're mad at me, aren't you? Yeah, you are. That's all right. Okay, fractions, decimals. Fractions, decimals, decimals, fractions. Okay? Write that as a fraction. Boom, done. Should be that quick. 2800ths, right? Wrong. Why? Yes! Good. Good. Keep going. Give me the answer. What? Over 100. Keep going. 7. Prime number in there? Heck yeah. Done. Absolutely. And they got nothing in common either. That's what you do. Do you know if you use this and it was a mistake, you made a much bigger mistake than right here? And why? If something is equal in relative value, you see these two are really what? They're really what? Yeah. They're equal in relative value. They are not the same. They are equal in relative value. So if two things can be equal in relative value, wouldn't you prefer, if you're going to make a mistake, make a minimal mistake? Hello? Hello? Yes? So reduce, 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 correct? Why? Not because Giles said so, because that's what y'all are going to tell your teachers. Why? Because if a mistake, an error is made, it'll be minimal. At least it'll be the least type of mistake. And let me tell you, where time is involved, where time to attempt to reverse something, that's critical. Good. Dealt with decimals. We dealt with this. The chapter just goes on and gives you all these explanations, all the change this, find the common denominators between these two. You know what? That's elementary. Elementary. You can do that. I'm just bringing out the most important factors that I expect you to show in your procedures, and then develop a discipline that is just that exacting. If math is exacting, then you can be exacting in its application, correct? Just don't get somewhere where you're understaffed and you're working all these hours and nobody wants to tell. Okay, percents. Per, just what it means. Cent. Out of what? 100. Out of 100. Out of 100. If I move the decimal point, how many times am I going to move a decimal point? Twice. Do you see 2 zeros there? That's what it is. Per 100. It's just a matter of which way do we go with the decimal. Okay? So, and at first, the best way to do it is just to do it in an approach of theorem. I'm going to come over here because I'm being prejudiced. I'm just staying over there. So now you guys stretch your eyeballs. Oh, by the way, decimals kill. Decimals kill. 10 times. One movement can kill a child. One movement, one placement, one, not 100, 10. 1/10 movement in the wrong direction with a decimal can kill a child. Absolutely. Somebody here might have one of those situations. But decimals kill folks. Put them on a cooling board. Pay attention. Where is the decimal? What is it doing? What is it supposed to do? Okay? So, we've got 0.65. And we need to take this to a percent. A percent. You are essentially multiplying it by what? 100. Now, moving the decimal, how many places? 2 places. So this becomes 1, 2, right? So the answer is what? 65%. 65%. Now let's go backwards. This is 65%, and I want to make it a decimal. I do what? Divide by 100. Now, if I moved to the right when multiplying, I'll move to the where when dividing. Because division is what? Opposite of multiplication. There's nothing strange here. Stop trying to multiply and literally walk through the logarithms of it, okay? The steps of it until you really get it down. I don't expect you to know it right away. I expect you to practice it so when you get it, oh, I know which way. To the left, to the right. Trust me. Y'all gonna go this way. I'm going to give you, and I'm going to say multiply this by 1,000 milliliters because I want a 65% strength drug. Do you know what some of you are going to do? You're going to take 1,000 and multiply it by what? 65. Okay? You do not multiply by the percent. This tells you what the number is. You're not supposed to use this number as a multiplicand. Okay? So now I'm saying that, here's the story. I'm going to erase this. I want a 7%, I want a 7% strength drug. We're going to put 7% in there. And we're going to do it in 5 mLs. How many grams in there? So you just need to simply multiply. How do I multiply? I have to take 7% and make it a decimal. Okay? So we're going to go from percent to decimal. Right? Correct? You multiply by the decimal, not by the percent. Multiply by the decimal and not by the percent. You're going to have this in a couple of weeks. Again, note, multiply by the decimal equivalent and not the percent. So that says I have to take percent and do what? Convert it or change it to a decimal. And percent, how many movements of the decimal? 2. Two. Give me 2 in another language, please. Huh? So, come on, holler. Another decimal, another language. Huh? Dois. What language is that?
Portuguese.
Good. Dois. Do, 2. Got it? This, they make big mistakes. We ain't making the mistakes this year. And I will give this to you. I want the percent of grams that are supposed to go in 5 mLs. 7 times 5 is 35. You'll kill that person deader than a doornail. Do what? Going from percent to decimal. 1, 2. What goes in here?
0.
What goes in here? Decimal? And there you go. So we take the decimal now and multiply it by 5. Now, here we go. We move chapters. We're going to take 5 times 0. What? 0.07. Don't grab your calculator. When multiplying decimals or fractions or numbers or multiplicands with decimals in it, here's the rule. When multiplying using decimals, you multiply immediately the whole numbers, right? This is a multiplicand. And this is a what? multiplicand. What is this? The product. So you take the whole numbers. 5 times 7 is what? 35. Now how many times do I move the decimal?
2.
Twice. How many decimals here? 0. How many decimals here?
2.
Which way do I move the decimal?
Left.
From right to left. 1, 2. And the answer is 0.0. No, I'm sorry. 1, 2. There you go. You see how quickly you can make a mistake? What is that answer?
0.35.
What is the answer?
0.35.
What is the answer?
0.35.
No.
0 and 100.
No. Remember? Huh? How would you say it? 3/500 gram, if it was grams. 3/500 grams. You do not have to say 0 and. Remember, 3/500 grams is the same as 0 and 3/500. So for efficiency and making minimal amount of mistakes given verbal instructions, that is 3/500 of a gram or gram. And your author really says, you know what, we can make a lot of mistakes given verbal instructions. 3/500 gram. Or you can say 3/500 of a gram.
It would be better to say the number out.
3/500 gram.
So
0 and 35. I'm saying that's fine. Okay? But you'll get to the point where the answer is 3/500 of a gram.
So you write it for the answer?
You write it, yes. Remember, verbal, written. Verbal is one thing, boom. If you're writing and you're transcribing, they tell you give it back. Do you mean 0 and 0.35 gram? And we'll say yes. Your author wants you to do that as you're exchanging. Does that happen though? Not a lot. Why? Because we're under the gun. We're understaffed and things like that. But it's someone's life. I don't consider it understaffed. I consider that each person, you know, my wife is really good at that because if she's talking to you, for instance, she'll completely ignore me till she's finished. Just act like she don't even hear me. You'll wait till I'm finished. And sometimes that's the way we need to be. Each person deserves to get the same amount of care, whether they have a runny nose or whether they have something else that appears to be more obvious. How do you don't know? You might not know that that runny nose might be accountable to something else. Allergic, allergies. And the person begins to get migraines, but you just like, your nose is just sniffing. I got to get over here. Be careful. 35 grams. Okay, the rules here in chapter 2, when multiplying, okay, multiplicands that have decimals in it, you multiply the whole number, boom, and then in your product, bring back the number of valuations that you have in both multiplicands as decimals. This is 2 because there's none here. Yes.
So you can't do a 0.07 times 5, it should be the whole number on top.
It doesn't matter which way you do it. It doesn't matter how you set it. It's multiplicative and distributive. It doesn't matter how you set it up. You set it up anyway. The rules of the matter is what goes in your calculator, for instance, is 5 times 7. If you can't do it in your head, 5 times 7 goes in your calculator. We do not put decimals in our calculator. We let our calculator give us decimals in our answer. But in your practice, you do not put decimals because you'll keep putting them in. And the more you put in, the more mistakes you're going to make. It is not necessary for you to put decimals in the calculator. Now, it may seem awkward, and you're going to cheat. And you're not going to learn how to be as efficient. Because, see, when I look at this, I see 35. I see 35, and I'll handle the decimals in the answer. I want to handle the decimal all by itself because it does what? If I can handle it one time instead of 2 times and then putting it actually in, I'm going to give you I'll give you 100 problems with decimals in it and multiplicants, and I'll tell you, you will be so sick putting in decimals, you won't even know which decimals you put in that were right and which were wrong. But I can guarantee you, if you handle each one here, you handle that decimal one time, then you go to the next one. Trust me, 5 times. I see 35, and then I'll handle the decimal.
Can you repeat what you said when multiply using decimal, you multiply the whole number?
Yeah, when multiplying, and in your multiplicants, you have decimals. You multiply the whole numbers, and then in the product, bring the decimals back from right to left in exactness to the total number of decimals. Now here, we just had one multiplicand, correct? With decimals. Let's do this quickly. Let's take a number like 6.25 times 0.8, okay? What goes in the calculator? Quickly. 625 times 8. Put it down and then bring your decimals in. Now, trust me, when I give a test and you're looking for 5 minutes and everyone has multiplying and division of decimals, you're going to appreciate this. You'll finish. Some of you will finish and the others won't finish because they're busy putting in transactions that they don't need to put in. Now, what goes in the calculator? 625 times 8. How long did that take? Now, look, what is the number?
5,000.
5,000? Even?
Yeah.
Whoa. Okay. Let's do that. That was too cool. I should have known. No, I took 25 and then 8. I should have known it was going to give me some stupid number with zeros in it. 8 times 5 is 40, right? That's a 0 at the end. Okay, quickly, what did you get? 4.
4904.
4,904, Professor. Okay, now what do I do? Now we deal with the decimals. Once. How many times?
3.
3. 1, 2, 3. Your answer rounded to the nearest tenth is 4.9. Your answer rounded to the nearest hundredth is 4.9. Your answer rounded to the nearest thousandth. 4.904. 4 and 904 thousandths.
What is it for the thousand?
4 and 904 thousandths. That is the correct verbal.
Can you say it one more time? I'm sorry.
4 and, right, decimal, 904 thousandths. It is not 4 and 900 and, okay? No. 4 and 904 thousandths. Now, when you're giving that, somebody might make a mistake and literally write 4,904. Double check. Errors can be made. Excellent, excellent example. What are the rules when multiplying with decimals? Huh? Multiply the whole numbers, which the multiplicants, and then in the product do what? Okay? Will I know if you practiced it that way? Eventually, in the end, you know why? Because you'll struggle. You won't find that, these little things save your time. They're efficient, and you become proficient when you practice. When you practice. Please don't undermine. Yes, we can multiply, but that's not what I'm trying to get you to do. I'm trying to give you the right logistics, the right way to approach dosage calculation. I know you know how to use a calculator. Okay? I got one more. We'll be just a couple minutes late. The other one. This is good because we will save proportions by itself, ratios and proportions by itself, and that will be the next week. Okay? So you're actually going to have 2 quizzes. You're going to have the quizzes up to everything dealing with fractions, decimals, a percent, okay? And then multiplicants with decimals, and here's your last one, the one that's the most hated. Save the best for last. When dividing decimals with or dividing decimal fractions, or what? Where the numerator has a 1 in it, maybe? And the denominator has a 1 in it. Good, good. So let's take 6.14, and then now let's divide it by what? 0.8. Okay, here's the rule. What does not go into the calculator? Decimals. What goes into the calculator?
The whole number.
Whole numbers. Whole numbers. Okay? Now, in multiplication, are you with me? Are you with me? Give me 2 minutes. Give me 2 minutes. Are you with me? In multiplication, in your final answer, in your final approach, you brought the decimals back in. What do you do with division? Bring them out. This is easy stuff, y'all. So we're going to take the decimals what? Out and put the whole numbers in. Doesn't that make sense? How can something be exact and symmetric if one is the opposite of the other? Then to be symmetric in total responsibility, you got to do the exact opposite. If you think that way, you never have to memorize. Okay, so let's take this out and divide by whole numbers. Now here's the key. We have to keep it proportionate, the same. So what you do in the top, you do in the bottom. So how many decimal places do we have to move to make whole numbers out of both of them? 2. So what do you divide? See, I see this. I see this. You're taking 614 and dividing it by what? 80. There you go. Plug it in. Plug it in. Plug it in. Plug it in. Now round this to the nearest hundredth. I hope this don't come out even. Round it to the nearest hundredth. And you got an idea. See, now let me show you something. You ain't got a clue what the answer really could be. Here, though, you got some idea that when you get that answer, it's going to be pretty good, you know? Oh, yeah, I can see 80 going into 600 around 7 times. Why? Because I can see 8 going into 61. How many times? You know? But you can't get that from here. These decimals is just messing you up. So, get them out. When something messing you up, kick it out. Don't y'all go home and kick out your significant other. Then I go to cross the street, somebody trying to run over me. All right, what is the answer to the nearest, what did I say, 100? What is the answer, please? 7 and 68 hundredths. Is that what you got? Okay. I gave you 2 examples. I don't need to give you any more. You basically put your own examples in. See what I do? I just make up numbers. I make them up. Just like we did here. I'll throw a couple numbers in. I'll put 3 decimals on the top and 2 at the bottom and here and come out with the answer. These exercises are in your book. Use them. Okay? Come to lab. All we do is reinforce this. And we actually did a good piece of 3%, and I showed you proportion. You understand proportion. What is a proportion? What is proportion? How is proportion used? 2 ratios that are what? Proportions are nothing that, no more than 2 ratios that are equal in relative value. How do you keep them relative? Would you start with a ratio? What you do to one, you do to the other. If you don't, you will completely change the prescription. You'll change the weight distribution. You can hurt somebody really, really, really bad. Okay. Do this. I'm going to flash this up here. Please help me out to get you out of here. Okay, can you see that? Yeah. All right. I'm going to, oh, Lord, have mercy. Okay. Is it NEP? Here, please say here. Yeah. Okay. Bridget, you see where I'm going down the line? Yeah. Okay. So Bridget's not here. She's going to be marked absent. Carolyn. Here. Cindy. Here. Help me out. Chapui? Yeah. Jeptui? Jeffrey. Huh? Which one is number 5? She's not here?
I'm here.
Okay, well, please, help me. Help me out. I don't know your names. You know mine. It's simple. I'm Professor Giles. Y'all is like 40-something in here. Help me out. Okay, all righty. Where are we? Jeffries? Jeffrey, how do you pronounce that?
Jeffrey.
Okay, Lisa.
Her daughter's sick. She's not here.
She's, huh?
Her daughter's sick. She's not
Okay, thank you very much. She'll come in. Tell her to see me for an excuse,
here. Yeah, she's
please.
emailing you. Yeah.
Jessica?
Here.
Carrie? Elaine?
Me here.
Dolores? Cherish?
Here.
Okay, Melissa?
Here.
Samantha?
Here.
Is it Marshina?
Here.
Okay, Shelly Ann?
Here.
Anthony? Anthony Ledbetter? Okay. Good. Chelsea?
Here.
Jenna?
Here.
Rosita?
Here.
Jacqueline?
Here.
Anna?
Here.
Lele?
Here.
Is that Lele?
Yes.
Okay. Maxine?
Here.
Elena?
Here.
Noah?
Here.
Or Noel? How is it?
No.
Okay, somebody help me.
Victoria.
I'm going to say Victoria. Here or not? Numbers 27. Okay, that one's tough. Y'all got to admit. Christy. Ryan.
Here.
Ram.
Yeah.
Okay, Amanda.
Here.
Ronald. Okay, Kimberly.
Here.
Is it Terica?
Yes. Here.
Okay, Lauren.
Here.
Kara.
Here.
Ashley.
Here.
Tanya.
Here.
Nadia. Miss Wright? Okay, done. If there's somebody that I did not, let me see here. I think that's it. Everybody been called, mentioned? Good. Quiz, it'll take like 10, 15 minutes, usually at the end of the class. Here, pass.